So, welcome to the video on lines. Okay, if some of you are maybe coming back after a break, some of you might be just have finished up graphing the equations. Either way, let's look at our skill objectives and conceptual objectives for this video. The first one, the skill objective, is graph a line. Pretty sure most of you can do that, but we'll talk a little bit about that as well. Number 2, calculate the slope of a line. Number 3, find the equation of a line using slope-intercept form. The fourth one is find the equation of a line using point-slope form. I will tell you, the point-slope form is, well, for many of you, it's one that you probably don't use very often, but it is the one I mainly use. So, and I'll explain why when we get to it. The last one is to find the equation of a line that is parallel or perpendicular to a given line. Our conceptual objectives. 1, classify lines as either increasing, decreasing, horizontal, or vertical. And to understand that slope is a rate of change. It's real important to remember that aspect about slope. That slope really is a rate of change because that is a key for what is happening when we go after this class into calculus, when we start dealing with rates of change in many different situations. In terms of the equations of a line, here's the three common ones that you see. The first one is general form. Sometimes I've seen it called standard form, but this book calls it general form. In fact, so we'll use that. And that is the equation ax plus by equals c. Okay, that's in general form. And a lot of times when people have it in general form, you won't see any fractions. So it'll all be integers, or there won't be fractions. The next one is slope-intercept form, probably the one that most people know and people are most familiar with, and that is y equals mx plus b. The third one is point slope. Point slope is y minus y1 equals m times x minus x1. Now in terms of those two equations, the last two, slope-intercept, point slope, m is equal to slope. Why m equals slope, I have no idea. It just happens to be that I'm figuring that in some language, the word for slope starts with m, and that's probably how it came about. The y-intercept is b. So when I see in slope-intercept form, when I see that whatever number is in that spot doesn't have the x, that is going to be where the graph will cross the y-axis. Slope-intercept form is excellent for graphing a line. It is not the best one for finding the equation of a line, unless you happen to be given some real basic information. In terms of point slope here, the point, when I look at this, you see the subscript variables here, the y1 and the x1. That happens, those two values will be the coordinates of a point that is on that line. I told you before that I prefer point slope when I'm finding the equation of a line. Part of the reason is, number one, when I was in college, that was the only equation, only form that was used by college professors for finding the equation of a line. Unless they happen to be given the y-intercept, then they would probably use the slope-intercept form. And honestly, in a lot of ways, in a lot of situations, it actually will be easier for you to find the equation using point slope. So I would like you to really make an effort to use that one. Now let's talk about slope. We use m to represent slope, and what you see here, I've given you a graph, and we have 2 points. This point at this location is the point x1, y1, and that point right there is the point that's x2, y2, x sub 2, y sub 2. And when we talk about this, when I go from this point to this point, there is a change in x, which is this part, and there's a change in y here. The change in x is called the run, and the change in y is called the rise. And what we know, slope, also known as m, is equal to rise over run. That's a very common one. If you keep that in mind, that can help out. Also, keep in mind it is the change in x over the change in y. And we have this formula that you probably are familiar with, y2 minus y1 over x2 minus x1. That is the slope formula. And I can calculate the slope by using that, plugging in the y coordinates and the x coordinates into those spots. Now, which point you call the y1 and x1, which one you give that, that's up to you. but just be consistent, okay? Now the other thing I want you to keep in mind, and this is in terms of interpreting slope. Slope tells you how y changes when x is increased by 1. If I tell you a line has a slope of 3, that means every time 1 is added to x, my line is going, the y values are going up by 3. If I tell you the slope is negative 1/2, every time x goes up by 1, y drops, gets smaller by 1/2. So keep that in mind as well in terms of the meaning of slope. What you have now here is 3 sets of points, and we're going to go through and find the slope of the line connecting those given points. Let's take a look at the first one. When I do that one, remembering that the slope formula, that in slope, I know m equals y2 minus y1 over x2 minus x1. I want to find the slope of the line connecting 3, 5 and 1, 7. And so that slope for that line is going to be m equals 7 minus 5 over 1 minus 3, which in this case gives me positive 2 over negative 2, so that slope would be negative 1. What I'd like you to do right now is pause the video, and I want you to find the slopes of the second and third lines. So pause this video, do those, and once you've done those calculations, come back and we'll go through them. Okay, welcome back. Let's take a look at the second one. In terms of that slope, you should have come up with 1/5, and you'll see how I've set it up. I tend to use, for consistency's sake, I usually pick a pattern and be consistent. I end up using this second point as the x2 and y2. So I plug those in, and then this point would be the x1, y1. I plug it in, and I got 2 over 10, which when I reduce it would give me 1/5. The third one's a little bit more interesting, because if I set it up the way I did, I used, again, this was the second point, so x2, y2, and then x1 and y1. When I plugged it in, I got negative 3 minus 2 over 4 minus 4, which gives me negative 5 over 0. Well, negative 5 over 0 is not defined. That's an undefined statement. So when that happens, when you get a number, some number other than 0 in the numerator, but you do get 0 in the denominator, like we did right here, what you're going to do is, in that situation, we have no slope. And when you have no slope, that is a vertical line. In terms of slopes, what you want to keep in mind, if a line has a positive slope, that line is said to be increasing. If you go through and have a line, if you look at a line that has a positive slope, you read a function like you read a book. You move from left to right. As you move from left to right, when the line has a positive slope, it's going up. So that's why we say the line is increasing. If the slope is negative, if it's less than 0, then as I move from left to right, that line is going to be going down, so it's decreasing. If the line has a slope of 0, notice having a slope of 0 is different from having no slope. Having a slope of 0, what you're dealing with is a horizontal line. In that situation, you have a horizontal line, and you want to remember that the equation for that line is just going to be y equals c, and whatever, some constant c. And you'll be able to tell what it is by just looking at the y coordinates of the 2 points that you had when you found that slope, because those 2 points have the same y coordinate if the slope comes out to be 0. If you have no slope, and remember, no slope means that when you use the slope formula, you ended up with a division by 0. That's when you have a vertical line, and the only way that's going to happen is when the x coordinates of the 2 points are the same. And so the equation of that vertical line is going to be x equals that c, whatever the x coordinate was in the 2 points you saw. Let's talk about graphing a line. In terms of going through and graphing a line, the slope-intercept form is definitely the best way to go about graphing a line. So in this case, what I started out with is I have a line. The line I had was 2x plus 3y equals 9. And I want to go through and graph that line. So I want to the first thing I want to do is put it in slope-intercept form and then identify the slope m and the y-intercept b. To put a line in slope-intercept form, that's just a fancy way of saying solve that for y. So what I did is I started out by, in this case I went and subtracted 2x from both sides. So I got 3y equals 9 minus 2x. And now I took the everything and I need to solve for y, so I have to get the y by itself. So I divided everything by 3 and reduced. In this case, when I divided by 3 and reduced it, I just ended up with y. Here I have 9 divided by 3 gives me 3. And in this case right here, you can't reduce it, so you get negative 2/3 x. Now remember, in slope-intercept form, the number that's with the variable is going to be the slope, and the number that doesn't have a variable is the y-intercept. So in this case, my slope is negative 2/3. My y-intercept is 3. Now, we are supposed to go, in this case, they want us to graph this line. Well, the way you graph the line is, in this case, when you have the y-intercept, you go up to the y-intercept, which is at 3, and I'm going to put a dot. So I put a dot right there at 3. And what the slope tells me, the fact that I usually put the negative sign, you can put it with the top or bottom, it doesn't matter. I usually put it with, especially when I'm graphing a line and I have the y-intercept, I usually always go through and put the negative sign with the numerator, because that tells me the rise is negative 2 and my run is 3, which means that I'm going to go down 2. So when I go down 2, I'm starting there. I go down 1, 2, and then I'm going to go over 3. So I'm going to go over 1, 2, 3. And that means that I'm going to have a point right here. That point goes down 2 and over 3. And now the nice thing about graphing a line in this way is that if you want to find another point, you can, but the line that we're trying to find just connects those 2 points. And so there's the graph of that line. Now, if you remember earlier, I said finding the equation of a line, I generally use point slope unless I happen to be given a very specific point. That specific point I would be looking for is, do I get the y-intercept? If I have the slope and I have the y-intercept, then I'll just use slope-intercept form. So in this case, on this problem right here, I'm given that the line has a slope of 4, 3, and it goes through the point 0, 2. Well, in this case, when you have an x-coordinate of 0, that means the number that you have right there is the y-intercept. So I know the point 0, 2 is on the y-axis, so I can say 2 is the y-intercept of this line, and therefore b is equal to 2. So when I look at the slope-intercept form of the line, y equals the mx plus b. All I did is I replaced m, because I was told that the slope, which is m, is 4/3, so I replaced m with 4/3, so I have y equals 4/3 x plus b. And then because I know the y-intercept is 2, I can just plug that in for b, so I get y equals 4/3 x plus 2. And that would then be the equation of that line using slope-intercept form. Like I said, that's the only time I really ever use that form for finding the equation of a line is if I am given the y-intercept. Now let's take a look at another example. Here's a problem where we're going to use point slope form. So in this case, I'm given that the slope is 2/3, and I'm going through the point negative 6, 7. So I have my point slope form. You'll notice I wrote it down there. Y minus y1 equals m times x minus x1. The next thing I did is I just replaced m with 2/3 like we had before. So I put 2/3 in there. And then I took my point. Now in this case, the x-coordinate of my point, that's negative 6. Remember, that is x1. And the y-coordinate of the given point is y1. So when I put in that point in there, I got y minus 7 equals 2/3 times x minus a negative 6. Or if I simplify that, I get y minus 7 equals 2/3 times x plus 6. If I'm supposed to go through and put it into slope-intercept form, I'd have to distribute. At this point, I would distribute the 2/3. And when I distribute the 2/3 here, I would get 2/3 times x is just 2/3 x. And 2/3 times 6, if you go through and do that calculation, you'll get 4. So I now have y minus 7 equals 2/3 x plus 4. And to put it in slope-intercept form, if that's how they want it, you end up getting, you add 7 to both sides, and I get y equals 2/3 x plus 7. That would be slope-intercept form. Now, this is my time to go through and tell you my philosophy on this. And I do this because part of this class is also going through is preparing students to either take the IB exam or the AP exam. And in general, on the free response portions of both of those exams, the feeling is that once you get a correct answer, you're done. So what you need to realize is the reason I tell people just to use this particular form is because when you got to this point here where y minus 7 equals 2/3 times x plus 6, there's the equation of a line. That's the equation of a line. It wasn't stated what form you needed to put it in, so that right there would be an acceptable answer to this problem, and you could have stopped. The only thing putting it in slope-intercept form does for you is gives you another chance to make a mistake, and quite honestly, I would prefer that you would just stop at this point on a test or quiz. Homework, make your answer match the back of the book, whatever form it is. But on a test or quiz, I would prefer you just stop there. Now let's look at the worst case scenario, line addition. Why do I say this is the worst case scenario? Because basically this is the hardest problem I could give you. The numbers can change, making it a little bit more difficult, but in terms of the concepts and what you have to do, this is as hard as it gets. What we have in this case is I want to find the equation of a line through the point 2, 3, and negative 1, 4. So what I have to do is that the first thing I have to do is I have to find a slope. If I have a point and a slope, I have the point slope form of a line, so I'm okay. In this case, I have 2 points, no slope, so I have to find it. So using the slope formula, I use the change in y over the change in x. So I have 4 minus 3 over negative 1 minus 2. And when I simplify that, I get 1 over negative 3, or I can just say it's negative 1/3. Now taking the point slope form of a line, I replace m with negative 1/3. Now in terms of the point you pick, that's up to you. You can use either one. So if I use the point 2, 3, then I get y minus 3 equals negative 1/3 times x minus 2. Or if I use the point negative 1, 4, I get y minus 4 equals negative 1/3 times the quantity x plus 1. So those would be the equation of the line, and that would be basically the most difficult thing in terms of concept-wise that I could give you. This now concludes our video on lines. So it's just been a crash course on a review for equations of lines. I hope this helped. I'm trying to see if it's a little bit shorter too. So what you should do now is after you've taken notes on the 2 videos, graphing and the lines, I'd like you to go ahead, write up your WISC, the WSQ. Remember, the first question is when and where did you watch the video? The second question is give me a summary of the 2 videos. And the third question is are there any questions or concerns that you have with the material that you would need answered? So with that, any problems that you can finish up from the last set, and I hope you have a good evening, and we'll see you at next class.